Well, I guess the thing that happened in 2000 was when we had gone to RoboCup in 1999 in Stockholm, there was a presentation there demonstrating how high school students could build robot soccer teams with Lego, really simple Lego devices, and didn't need the kind of engineering skills that the more sophisticated universities tend to. And what a great way to get high school students engaged with robotics. And the key innovation there was that there was a ball that had glowing lights inside it. So a very simple light sensor could detect where the ball is. And then a field that was dark at one end and got gradually lighter to the other. So you could push the ball in the right direction and the other robot would be trying to push it in the other direction, just by looking at how bright the field was when it looked down. What a great idea, great innovation. So I was keen to bring this back to Australia and to get Australian school kids playing robot soccer, built out of Lego, even though they're just in high school. And start to get passionate about robotics, passionate about programming and building hardware and different kind of hardware. So yeah, in 2000, we actually brought this program, RoboCup Junior, to Australia for the first time and hosted a competition in Queensland, then ended up hosting the Australian competition. We ended up hosting the international competition in Melbourne as well. And this has turned into a movement. It's still going. And it's had tens of thousands of students have now competed in RoboCup Junior, and a great number of them have gone on to do fantastic things in engineering. Actually, a story that comes to mind there is we had in the robot soccer competition one of the most advanced robots we'd ever seen, built by a bright young student called Will Madden. And he won the competition, competing for his school when he was just in year 9. He wasn't even a senior student. And he went on to, having sort of won the competition with a Lego one in year 9, he ended up building one himself and cutting metal and making his own circuit boards and all that kind of stuff as he went through his senior school. And so he was a really bright student. And so I helped support him to compete in the international competition, to go overseas, where he did really well. And then encouraged him to come and study mechatronic engineering with me. He ended up doing a PhD with me, and he graduated from that very well. Went on to do a postdoc at Oxford University, working with the robotics group over there. And now works on home delivery robots that are solving the last mile problem. How do you get the package from a base to someone's home? So that's one example of someone coming through the RoboCup Junior program going on to be part of the robotics revolution. In the RoboCup, there was a humanoid league, this idea for a humanoid league. So the vision of RoboCup was to have robots that were human-shaped to compete against humans, and beat the World Cup team. So we had to start somewhere. We've got to start building humanoid robots and find out how they go. Now, this is at a period in time when Honda had their Asimo robot, really famous humanoid, so delightful, so beautifully controlled. They'd made it sort of about 1.2 metres tall. And the great thing about being only a metre or so high is that if it fell over, it wouldn't kill you, unlike some of the bigger humanoids that had happened before that. So we thought, right, we can do this. We had $20,000, to try and build our humanoid. Asimo, never know how much it cost. It was clearly millions in terms of the way they did things. So, where Asimo had some of the finest engineering and capability in order to construct their chassis, we were bending sheet metal, and strapping it together. We got some nice motors in the end that we were able to use, PC motherboards that we were putting in different angles, and we made a lot of our own electronics. And we did get, at the end of the day, a robot that had about 20 degrees of freedom. all 20 motors. It had cameras. It had a computer vision system. It could see a football. It was able to shuffle across the floor. But the thing that killed us in the end, and really it probably shows the nature of my background as a computer systems engineer, not a mechanical engineer, was the skeleton we build out of folding sheet metal just didn't have the rigidity to deal with the dynamic forces of walking. So when the robot would go to lift its leg dynamically, the metal would just go, and it would be elastic, it would go back again, but the robot just across these 20 degrees of freedom just sagged. So we're commanding angles to get this foot, clear off the ground, and the metal's just sagging. So yeah, lightweight magnesium alloy or something, might have been nice to have, but that wasn't in the budget. So Guru taught a lot of students a lot of things, and produced some amazing students as well, and even just showing up for the competition and seeing what the other robots did. Yeah, it was good value.
Tell us the acronym Guru. What does it mean?
So Guru, G-U-R-U, stands for grossly underfunded RU.